Endoplasmic Reticulum, but you can just call it the ER. The one I'm talking about is the rough ER. It's called this because ribosomes are on its surface, and now you know why it's called the rough ER.
Good afternoon, everyone. I would like to start off by thanking all those who have traveled nanometers to be here today, to both the prokaryotic and eukaryotic parties. I am truly humbled by this experience and hope that I can make you believe in me the way I believe in you. I am the Endoplasmic Reticulum, and I work as a manufacturing and packaging system. You may know my personal assistants, Golgi apparatus, ribosomes, mRNA, and tRNA. We, as a group, work together to make the cell as happy, healthy, and functional as possible. You deserve a leader who can work well under stress and that is open to working with others. Unlike the mitochondria, who depends on its sole independence and prioritizes its personal production of ATP, leaving every other organelle behind. Cells that synthesize and release a lot of protein will need a lot of ER support, and that is why I'm here today. Lucky for them, I have two different versions, the smooth ER and the rough ER. My smooth ER is involved in the synthesis of lipids, such as cholesterol and phospholipids, and acts as a storage organelle. Our production of phospholipids creates phospholipid bilayers, leading to the formation of the cell membrane, which ensures that the entire cell stays intact. Without it, the cell would fall apart. I work to detoxify countless organic chemicals in the cell system and convert them into safer, water-soluble products. Without a smooth ER, you wouldn't have enough stored calcium ions in your muscles and would make you unable to contract them, leaving you unable to walk, move, and have limited brain function. Without a smooth ER, you will never be able to share that glass of champagne on New Year's, 2022 of course, because your body will not be able to break down the toxins into soluble substances. My rough ER is involved in synthesizing proteins, such as actin and antibodies. My work to synthesize proteins helps keep all humans alive and active. Actin forms contractile filaments of muscle cells, helping the muscles remain functional so that humans can move. In addition, antibodies combine with foreign substances to counteract its effects and prevent sickness. You may recognize me by my ribosomes that cling to my surface. Like them, you can follow me too, by voting for the endoplasmic reticulum. My rough ER is clearly very effective in protecting the human body, helping to make me one of the most useful and important organelles. In addition, my rough ER discards any misfolded proteins so that there aren't any poor effects on the human body. Then, my rough ER sends the proteins to the Golgi apparatus for transport. While the Golgi apparatus does play a role in the transport of proteins, we are the most useful organelle because we do all of the work, and all it does is take credit for our work because it transports our proteins. Without us, other organelles would not be able to carry out their own functions because they won't have the necessary proteins to do so, leaving them in a very destructive state. Not to mention the fact that sometimes it infects my proteins with its diseases such as Alzheimer's. So don't vote for an organelle that corrupts the work of others. Vote for me. My rough and smooth ER clearly participate in many vital functions that keep humans alive. So why would you vote for an organelle that doesn't give proper aid to the body? Without me, you wouldn't be alive. So take what I give you and vote for me. The endoplasmic reticulum. Thank you.
Endoplasmic Reticulum, but you can just call it the ER. The one I'm talking about is the rough ER. It's called this because ribosomes are on its surface, and now you know why it's called the rough ER.